Hello. I want to take this opportunity to welcome you back to our class. Today we are looking at Form 2 Maths, lesson number 3. Topic is linear inequalities. Subtopic representing linear inequalities on a graph. Steps that we need to know. 1, we must come up with x, y table for each particular linear inequality. If it has 2 unknowns, but if it has 1, there is no need. I will show you on how you can represent that kind of linear inequality. 2, you will need to draw lines representing each particular linear inequality. Then lastly, you will identify a common point which you will use to enable you to know the side to shape. I want to take you direct to our example, which will enable us achieve this objective of representing linear inequalities on a graph. So let's say example. Given the linear inequalities, y is greater than a half x, comma, y greater than or equal to minus 2x plus 2, comma, y is less than or equal to minus a half x plus 3, and y is greater than or equal to 1, comma, represent them on a graph. Solution. The first step is obtaining x, y table for each linear inequality. The first one is y greater than a half x. So we obtain xy for that given linear inequality. So we will make some assumptions by saying that what if x is 0? So if we come and replace x with 0, what will be the power of y? Y will be a half times 0. Y is equals to 0. So what if x is 2? So y will be y greater than a half times 2. 2 and 2 will cancel. Y becomes 1. So this is now our xy table for this linear inequality. The next one is y greater than or equal to minus 2x plus 2. Let's come up with xy table. So what if x is 0? In that case, then y will be y greater than or equal to minus 2 times 0 plus 2. Y greater than or equal to minus 2 times 0 is 0, then plus 2. That means y is greater than or equal to 2. Therefore, that is 2. So what if the power of y is 1? The power of x is 1. So we will come and say y will be greater than or equal to minus 2 times 1 plus 2. Y greater than or equal to minus 2 plus 2. Y greater than or equal to 0. Let's move to our next linear inequality, which is y less than or equal to minus a half x plus 3. xy, what if we say the power of x is 0 in that case? Y will be less than or equal to minus a half times 0, then plus 3. So that means our power of x, our power of y will be less than or equal to 0 because minus half times 0 is 0, then plus 3. Therefore, our power of y will be 3 in that case. So what if we say the power of x is 2? Our y will be less than or equal to minus a half times 2, then plus 3. Y less than or equal to 2 and 2 will cancel, we will remain with minus 1 plus 3. So y will be less than or equal to positive 2. The last one is y greater than or equal to 1. For this one we have 1 unknown. So I am going to show you on how we represent this one on the graph. Now I want us to draw a very simple graph which we will use So I want this line to represent y-axis, this one to represent x-axis. So where they meet is our point of origin. That's where we are, our 0. The scale I want us to use is 1 square to represent 1 centimeter. So this will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The first one now. For us to be able to represent y is greater than a half x, we will use these points. 0, 0 is at the point of origin. 2, 1. 2 on x-axis is here. 1 on y-axis is there. They converge or meet at that given point. And remember, when you are plotting graphs, you use process only. Therefore, you join the 2 points using a dotted line because we are greater than only. There is no equal to. So this line is not going to be continuous. Then you will let that line as y greater than a half x. We will now identify a common point which we will use in all these inequalities for us to know the side to shade and the side not to shade. So for me, I want us to identify this given point, which is 1, 2. So when we come back here and use 1, 2, where 1, 2 means 1 is x coordinate, 2 is y coordinate. So if we have y greater than a half x, and y in our case will be 2, our x will be 1. So this means 2 is greater than, this is times 1, that is a half. Is it true to say that 2 is greater than a half? If it is true, then we cannot shade the upper region where the point is. We will shade the opposite region. That one now is well done. Let's move to this 0, 2. 0 on x-axis, and y-axis 2. They meet there. 1, 0. 1, 0. We join that. In this case, we will use a continuous line because we have greater than or equal to. With a continuous line. Now, once we are done, we label that y greater than or equal to minus 2x plus 2. Then we will use this same point to prove the side that is required to be shaded. Then we will come and say y greater than or equal to minus 2x plus 2. Our y in that case is 2, x is 1. This will be 2 greater than or equal to, this is minus 2 plus 2, 2 greater than or equal to 0. The statement is very true. 2 is greater than 0. So we don't shade that part, we will shade the opposite one. So we will say, this is the region that is not 1. Next, we will look at these points, 0, 3. 0, 3, then we have 2, 2. 2 is here, on the y-axis 2 is there, so they meet at that given point. We will draw again a continuous line because of less than or equal to, there is equal to, which is dictating that we draw a continuous line. Okay, this point is 0, 3. 0, 3 is at this given point. Note down here. So for this one, it should be drawn this way. Yeah. Because 0, 3 is at that given point. 3 is on y-axis. You can get to see that. Then we label it as y less than or equal to minus a half x plus 3. Once we are done, we now prove. So as you can be able to see which side is supposed to be shaded and which one is not supposed to be shaded. Coming here, we will say y less than or equal to minus a half x plus 3. Y is 2 according to our point of difference, minus a half times 1 plus 3. 2 less than or equal to minus a half then plus 3. That means 2 will be less than or equal to 3 minus a half is 2 and a half. The statement is very true. So if the statement is true, we cannot change the region where the point is. We will change the opposite side. And lastly, we have y is greater than or equal to 1. So for this one, we go direct to y-axis and identify where 1 is. Then we draw a straight line. You draw a straight line. Then you label that one as y greater than or equal to 1. The line is continuous because equal to of the equal to in that particular inequality. So now, having y greater than or equal to 1, use this particular point to know the side to shade. Y is 2 because we don't have x. The statement is very true. You cannot shade that part where the point is. You will shade the opposite one down here now. So the region that is now left unshaded is the required region. You left that one using the capital R to show that that is the one region. That region, any point in that given region satisfies. It will satisfy all of the 4 linear inequalities. Thank you for listening to me. God bless you. If you have a question, put comments and ask. I will answer you. See you next time.